right, we have ourselves a nice little rational function, g of x, and we're being asked 6 questions about it. So first things first, the domain. The way you find the domain of a rational function is you figure out the numbers that make the denominator equal to 0. So in order to do this, what I have to do is I'm going to rewrite this guy. The numerator I really don't have to rewrite because the numerator isn't important for the domain, but I'm going to write it out anyway because I started it. And I had to factor out the denominator. X squared minus 9 is difference of squares. That factors out to x plus 3 and x minus 3. Now, the two numbers that make the denominator equal to 0 would be -3 and 3, which means I'm allowed to plug in any number I want except for -3 and +3. So that gives me a domain of everything, negative infinity, up to -3. I'm not allowed to plug in -3, so I'm going to union it and make it -3 again, because you're not allowed to include -3. -3 to 3, union 3 to infinity. Okay? That's the domain. Now to find the y-intercept, I'm going to focus on when x is equal to 0. That's kind of a long way of doing it. So what I can do is I can FOIL out the top but only focus on certain things. Now I know what I can do. I know what's going to happen. All right. And I'm going to be a little lazy here. Since I'm answering questions about the limit, I'm going to kill two birds with one stone. I'm going to leave the denominator the way it was originally, and I'm going to find the leading coefficient and the last constant of what's completely up here in the numerator. So part number 1, the way you find the leading coefficient is you multiply the leading term in every factor. 4 times x is 4x squared. I don't care about what's in between. Don't care. The way you find the constant is you multiply every constant in every factor. So that's 4 times 5 times -2. 4 times 5 is 20. 20 times -2 is -40. So the y-intercept is going to be the constant divided by the constant. -40 divided by -9 is just going to be 40 over 9. Now, the limit as x approaches negative infinity is found by dealing with only the leading coefficients. Now, my leading coefficient is 4x squared over regular x squared. So a little shortcut is I can view the leading terms, not coefficients, but the leading terms as 4 over invisible 1, or just 4. So when I plug in negative infinity in air quotes, when I plug in negative infinity, I get 4. And when I plug in regular infinity, I also get 4. Which means as x increases without bound, the g of x approaches 4. Remember, my end behavior gives me a y or a horizontal asymptote. And that horizontal asymptote is going to be at 4. As x increases without bound is just fancy talk for saying as x approaches infinity. So g of x is going to approach 4. Similarly, as x decreases without bound, the same exact thing is going to happen, and g of x approaches 4 once again. Okay? So 6 questions based off of this rational right here. Fun stuff.